Okay. Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan selamat malam semua. Okay, hari ni lambat 7 minit, minta maaf semua Macam mana cuaca dekat tempat you all semua? Di sini hujan tak berhenti dah almost 2 hari dah ni. Okay, tak berhenti-berhenti. Tempat hujan juga kan? Okay, so malam ni sangat sejuk. Saya tak nak buang masa kamu lah. Kita terus kepada hari tu kita berhenti dekat chapter 3, chapter 4, part 2. So malam ni kita akan sambung part 3 dan kemudian chapter 5, part 1 and part 2. So hari ni kita akan habiskan semua sekali chapters. Kemudian habislah for this semester for OOP ni. Kita ada 5 chapter je. Kemudian you all boleh maksudnya boleh teruskan buat apa yang projek yang diberikan. Nanti saya akan inform tentang projek after lecture ni Okay, saya juga sekali lagi pada malam ni jemput Cik Muhammad Izzuan sekali lagi untuk lecture. Okay. Okay, terima kasih pada Cik Muhammad Izzuan kerana sudi sekali lagi untuk menghabiskanlah sebab hari tu kita chapter 4 part 1 part 2 okay, Cik Izzuan telah terangkan. So kita sambung sekali lagi. Cik Izzuan ada kat sini? Okay, so saya rasa okay, Cik Izzuan boleh teruskan je lah. Terus saya kali ni saya dah berikan awal kepada Cik Izzuan slide, mungkin Cik Izzuan boleh terus share kot slide yang telah saya berikan. Okay, kepada yang lain, happy listening. Tak faham tanya direct tanya. InsyaAllah Cik Izzuan boleh terus berikan penerangan dengan jelas, insyaAllah. Okay, boleh teruskan Cik Izzuan?
Okay.
Okay.
Alright. Okay. Boleh nampak tak skrin ni?
Part 2 kan?
Boleh.
Part 3.
Boleh nampak Okay. Assalamualaikum and good night everyone. So tonight we're going to learn about continue this chapter 4 part 3 about object and class. Alright. So for tonight is the learning outcomes. So tonight you'll be able to know about the scope of variable, understand these references. Number 3, understand and know how to use abstract class. So tonight we will learn about abstract class. So the scope of variables. A variable defined inside a method is referred to as a local variable. So the scope of a class variable is the entire class, regardless of where the variables are declared. A class, variables and methods can appear in any order in the class as shown in figure 1 below. So this is the example of the class named
Sorry,
circle.
sir.
Yes.
Slide tak bergerak.
Slide tak bergerak?
Ya.
Slide tak bergerak
Saya kan Cik Zan bercakap ke tepi, so macam kita orang tengok. Ya, kita orang pun ada slide kan, jadi kita kan, okey. Ya, memang slide tak bergerak?
Ini gerak tak? Tak gerak?
Tidak.
Tidak Ini nampak
Ya okey. Okey ni. Alright.
Boleh? Pakai link je lah.
Oh tadi Cik Zan buat slideshow?
Ya.
Oh, okey. Okay, thanks yang tadi bagi komen.
So this is the example of the class circle. Here you can see the method called find area and the properties here. Double for radius. Okay. So the scope of variables, the exception is when a data field is initialized based on a reference to another data field. In such cases, the other data field must be declared first. So let's say there's two variables, right? So I and J. If J refer to I must be declared first. Okay. So you can declare a class variable only once, but you can declare the same variable name in a method many times in different non-nesting blocks. If a local variable has the same name as a class variable, the local variable takes precedence and the class variable with the same name is hidden. For example, in the following program, X is defined both as an instant variable and as a local variable in the method. So here you can see in this class F, there's a X and Y variables. This is called a class variable, X and Y here. It's declared as a private. Then we can see here, the same variable X is declared in the method called P. So when there's a two same variable declared in a class, this method variable will take precedence, and the X variable of the class here will be hidden. So when this system out that print line X here refer to method variable here, which is equal to 1 and not 0. The this reference, the this keyword is the name of a reference that an object can use to refer to itself. So you can use this keyword to reference the object instance members. For example, the following code in A use this to reference the object's radius and evokes its getArea method explicitly. So the this reference is normally omit as shown in B. However, the this reference is needed to reference hidden data fields or invoke an overloaded constructor. So as we can see here in A, there's a this here, this. You see, this dot radius, this dot radius. So this dot radius here refer to the class variable here, radius. And this dot getArea here refer to this class method. So in B, we can also see radius times radius here. This is a formula of getArea. This one also is referred to the class variable here, radius, for radius. This is equivalent. Okay. So using this to reference hidden data fields. The this keyword can be used to reference a class hidden data fields. For example, data field name is often used as the parameter name in a setter method for the data field. In this case, the data field is hidden in the setter method. So in this example, we have a class F here, and we have a variable, class variable I here, and K. This one is the class variable. And then we have a method here called setI. And then we have a parameter here, I. This one, this dot I equal to I. So this one, this.I refer to the class variable, where I here is refer to the parameter here, I. And we also have a method here, which pass the parameter k here, and we have inside the method, we have the f.k. F here also refer to the class F here, and k here is refer to the variable here, k equal to 0. So f.k equal to k means k here is refer to the parameter variable here. Okay. So using this to invoke a constructor. So the this keyword can be used to invoke another constructor of the same class. For example, you can rewrite the circle class as follows. So here in the example here, we have a class circle and we have a this.radius here equal to radius. So this.radius here is equal to the radius variable for the class circle. So the this keyword is used to refer to the hidden data field because because we have two radius here. So if you don't use this here, the program will get confused which one to refer to. So this dot radius will refer to class variable, where radius without this is refer to the method parameter. Okay. So and then we have the constructor here, public circle. This parameter parenthesis 1.0. This one means we call the constructor of the class circle here. It passed the parameter 1.0. The this keyword is used to invoke another constructor. So the line this in the second constructor invokes the first constructor with a double value argument. All right. So abstract class. Abstract class is a class with one or more abstract methods. An abstract class must have a modifier abstract included in the class header. The abstract class cannot be instantiated. It should be extended and implemented in subclasses. The abstract method signature without implementation. So this is the example of the abstract class. We have a geometric object here as a class. This one is a conventional class without it's not an abstract class, it is a conventional class. So geometric object, here we have a color here as a variable, we have field as a variable, and also date created as a variable. And then we have a method here, geometric object, this one is a constructor, and we have a get color here as a method, we have a set color here as a method, and is field, and this is the method. And then we have two other classes. We have circle and also rectangle. You see circle, we have two same method here, get area which return double and get perimeter which return double. Rectangle also has two method with the same name, get area double, get perimeter, and it returns double. Okay, this is the conventional class. All right. So an abstract class, we declare an abstract class like this. This one, geometric object, we declare as an abstract class. And then you see the get area and get perimeter in the circle and rectangle, we move to the abstract class. Okay. So this is the example of the abstract class. You see, this is how we declare the abstract class. We put abstract in front of the class, public abstract class, geometric object. This is the abstract class variables. And this is the abstract class constructor. And this is the method just now, which belong to the circle class and as well as rectangle class. You see, public abstract double get area and public abstract double get perimeter. As you can see, the abstract method, we just declare it and we end it with the semicolon without any implementation of the, like this one, without any implementation. If the method we declare as an abstract, right, it will not have the implementation code like this one. We just declare it. So this is the circle class just now. So this one is not abstract class. So this class will extend the geometric object. Public we define as public class circle extends geometric object. So this is the circle local variable, and this one is the circle method, which is get area. So we put the implementation here in the class that extends the abstract class. So we don't put the code inside the abstract class. We put the code inside the class that extend the abstract class. This one also, we put the code inside the class that extend the abstract class. All right. So this one also is the rectangle class, which extend the geometric object class just now. So it has a class variable here, and it also implement get area method as well as the get perimeter method. But the implementation is different. So for circle, right, the formula is different. The formula for circle get area is radius times math.pi. While in the rectangle, the get area formula is width times height. And the perimeter also is different, which is the perimeter formula for rectangle. All right. This is how you use the abstract class. So an abstract method cannot be contained in a non-abstract class. If a subclass of an abstract superclass does not implement all the abstract methods, the subclass must be declared abstract. So just now, the geometric object is a superclass, we call it superclass, and the circle and rectangle, we call it subclass. All right. So in other words, in a non-abstract subclass extended from an abstract class, all the abstract method must be implemented, even if they are not used in the subclass. Okay. Let's say you this circle extend geometric object, right? This one is the subclass, and there is a method here. These two methods here. These two methods is an abstract method, get area and get perimeter. Even if you are not using the get area, let's say you're not using this get area, you must implement it. You see, without the code. Right? You must extend it. If this class circle, you extend the geometric object, you must define or implement. We call implement. Implementation means a method with code, you see. So even if you don't implement it with code, you must put an open parenthesis and close parenthesis. This one is the what you call a must for a class that extend an abstract class, right? It must be implemented even without the code, or else it will generate an error. So an abstract class cannot be instantiated using new operator, but you can still define its constructors which are invoked in the constructors of its subclasses. Meaning that if you define geometric object is an abstract class, you cannot instantiate this geometric object, but instead you can instantiate the circle and rectangle class as an object. All right. For instance, the constructors of geometric object are invoked in the circle class and the rectangle class. Okay. A class that contains abstract method must be abstract. A class that contains abstract methods must be abstract. All right. However, it is possible to declare an abstract class that contains no abstract methods. In this case, you cannot create instances of the class using the new operator. This class is used as a base class for defining a new subclass. So a subclass can be abstract even if its superclass is concrete. For example, the object class is concrete, but its subclasses such as geometric object may be abstract. That means there's another class, superclass of the geometric object above the geometric object class. It's called object class. It can be not abstract, but the subclass can be an abstract class. Right? A subclass can override a method from its superclass to declare it as an abstract. So this is rare but useful when the implementation of the method in the superclass becomes invalid in the superclass. In this case, the subclass must be declared abstract. All right. So, any question for this abstract class so far?
Okay, open for Q&A. Jika ada, mesti ada kan? Ada yang blur ke? Ada yang any questions?
Why do we need to use abstract class?
So an abstract class is just like a template. We have one like common class here, and then the more specific class is down here. It's just a template. Normally, it's just a template for abstract class. You want the subclass to follow what method inside this superclass.
Oh, ada soalan lagi tu. If it's okay if we don't want to use abstract.
Yes, it's okay.
Okay. Kalau ada questions, kalau segan nak tanya direct, you can just tanya dekat ruangan chat ni pun boleh Tak apa, tanya je. Nak share soalan pun boleh kan Cik Izwan kan? Cik Izwan ni pakar programmer. So tanya je apa-apa. Ada masalah tak coding pun boleh insyaAllah. Ada soalan lagi? Tak apa, kalau masih lagi ada soalan boleh je berkaitan tentang chapter ni ataupun chapter sebelumnya pun boleh. Tulis je kat ruangan chat. Okay, kat sini chat tak ada. Kita teruskanlah 9:30. Okay, kita teruskan ke chapter 5 for chapter 5 part 1.
Chapter 5
Okay, untuk yang untuk kelas chapter 5 you all di dalam chapter 5 part 1 dalam week 11. Dalam learning materials week 11 Then part 2 is in week 12. Okay, saya dah bagikan slide kan pada Cik Izzuan. Part 1 chapter 5.
Okay. Continue.
Tulis je chat, tulis je soalan di chat ni. Anggapkan macam webinar lah jugalah. Okay, boleh? Sambil kita teruskan ke chapter 5 ni.
Okay. Kita teruskan
Ya. Ya, Cik Izzuan dah share ke slide but it's still chapter 4 part 1.
Chapter 4.
Yes. The slide that
Okay.
korang nampak ni.
Okay.
Oh,
Sekejap
okay. Okay.
Okay.
Alright. Cuba, cuba mungkin kita boleh try sekali lagi slideshow kot.
Slideshow.
Dah. Cik Izzuan dah.
Ada.
Tidak. Okay. Tak apa guys. Kita teruskan macam ni, macam tadi.
Kisah boleh share guna entire screen, try.
Entire screen Sekejap Entire screen.
Boleh. Boleh lah nampak.
Okay.
Asal dia macam ni, sir.
Nampak ke?
Dia jadi lain.
Dia jadi yang ada next slide tu.
Ni slide.
Apalah yang macam tadi je lah. Okay.
Saya kena pergi kat display setting saya.
Sekejap.
Dia kena buat apa? Macam mana?
Kena tekan display setting.
Oh. Okay.
Boleh.
Ya.
Okay. Okay, chapter 5 part 1, inheritance and polymorphism. Alright.
Last. Okay.
Second last.
Oh, okay.
Second last. So the learning outcomes, you'll be able to define subclass from the superclass to inheritance, to invoke the superclass constructors and method using the super keyword. So we use a class to model object of the same type. However, different classes may have some common properties and behaviors, which can be generalized in a class that can be shared by the class. We can define a specialized class that extends the generalized class. The specialized class inherit the properties and method from the general class. Consider geometric objects. Suppose we want to design the class to model geometric objects such as circle and rectangle. Geometric objects have many common properties and behaviors. For example, they can be drawn in a certain color and be filled or unfilled. Okay. Thus, a general class we call geometric object can be used to model all geometric objects. This class contains the properties color and fill and the appropriate getter and setter method. Assume that this class also contains the date created property and the get date created and toString methods. The toString method returns a string representation of the class of the object. Since a circle is a special type of geometric object, it shares common properties and methods with other geometric objects. Thus, it makes sense to define circle class that extend the geometric object class, like previous one. Likewise, rectangle can also be defined as a subclass of geometric object. So figure 1 shows the relationship among these classes. A triangular arrow pointing superclass is used to denote the inheritance between the two classes involved. So this one like previously one. So we have geometric object as a general class. And then we have a more specific class as a subclass, which we can see circle here and rectangle. All right. So the geometric object class is the superclass for circle and rectangle. Geometric object we call superclass, circle and rectangle we call subclass. All right. In Java terminology, a class C1 extended from another class C2 is called a subclass. So C1 is a subclass. C2 is superclass or parent class or base class. A subclass inherits accessible data fields and methods from its superclass and may also add new data fields and methods. Right? So these are types of inheritance. Number one is single inheritance. Class B inherit class A. So this one, the second one is multi-level inheritance. We have class C inherit class B, and then class B inherit class A. And then we have the third one is hierarchical. We have class B and class C inherit class A. So the circle class inherit all accessible data fields and methods from the geometric object class. In addition, it has a new data field, radius, and its associated getter and setter method. The circle class also contains the get area, get perimeter, and get diameter method for returning the area, perimeter, and diameter of the circle. So the rectangle class inherits all accessible data fields and methods from the geometric object class. In addition, it has the data fields width and height and the associated getter setter method. It also contains the get area and get perimeter method for returning the area and perimeter of the rectangle. So this is the example of the geometric object class. It has a private string, color, field, and also date created. This one is called a variable, a class variable. And then we have the public geometric object, which we call a constructor, which set date created as a new date. And then we have a simple geometric object as a method. So this here is called is referred to the class variable, this dot color, and this dot field also called refer to the class variable, where color here and field here is refer to the method variable, color and field, right? And there is a mutator and accessor. We have a method here, get date created, and also we have a toString method here, which return a string. All right. So this is how you declare a subclass. We have a public class, circle, extend. This is the keyword extend. Subclass, circle, extend, superclass, which is geometric object. And then we have circle class variable. Here it's called radius, and we also have a circle constructor here. So this dot radius here refer to the circle variable, where radius here refer to this variable method constructor variable. Okay. Then we have a method print circle here, which print the string the circle is created and date. Then the radius is, what is the radius? The variable, right? The radius variable. And this is the class which we a test circle. Okay, another class. Okay, this class is not the super class or subclass of any class, so it's just implementation class. All right, it has a public static void main. All right, so this is the circle class. We declare a C1. Here you create a new class called circle. It called a constructor, and it pass number 1, this one integer 1, to the constructor. All right, and it's called a system out the print line. A circle is toString here. C1, it called a C1 dot toString method here, and then we call a system dot out dot print line. The color is C1 dot get color. Right? If you see here, circle do not have toString method, right? So the method actually is inside the superclass of circle. Circle itself don't have toString method, but an object of circle class can access this toString method, which is the superclass of circle. Right? And also circle don't have get color method, you see, but just now we can see an object of circle class can call get color method, which is not the circle method, but it is it's a superclass method, which is geometric object class. Right? So this one is toString, and then get color, and then it call a system out print line. The radius is C1 dot get radius. So get radius here refer to get radius here is refer to a circle method, because the superclass don't have the get radius method, right? And also circle dot get area is referred to the circle get area method. Also circle dot get diameter is referred to the circle class get diameter method. You can see here get perimeter and get diameter. All right, it's more specific method for circle. So using the super keyword, the keyword super refers to the superclass and can be used to invoke the superclass methods and constructors. A subclass inherits accessible data fields and methods from its superclass. However, does it inherit constructors? they can only be invoked from the constructor of the superclass using the keyword super. The syntax to call a superclass constructor is super or super. If the constructor got parameters, it calls super and parameters inside the parentheses. Right? The statement super invokes the no argument constructor of its superclass, and the statement super arguments invokes the superclass constructor that matches the arguments. The statement super or super argument must be the first statement of the subclass constructor. This is the only way to explicitly invoke a superclass constructor. So let's say the circle, the just now class circle, which inherits the class geometric object as a constructor. If this class this one is the constructor. So if the class wants to call its superclass constructor, it must call like this, super and the argument here. It cannot call. It must be the first statement of this constructor. It cannot be down the this.radius statement here. It must be on top of the first one. All right. So that's all for this the part 1 of chapter 5. Any question? So far, any question?
Tak apa, boleh teruskan kot Encik Izwan ke part 2.
Part 2, okay. Alright.
Kalau maklum dah malam kan, ngantuk semua orang ni agaknya. Tapi kita dah kita record, hopefully diorang boleh tengok banyak kali lah. Okay, recording ni.
Okay, the part 2 for inheritance and polymorphism. So with the learning outcomes. So method overriding. To override a method, the method must be defined in the subclass using the same signature with or without parameter and the same return type as in its superclass. So a subclass inherits method from a superclass. Subclass inherit method from superclass. Sometimes it is necessary for the subclass to modify the implementation of a method defined in the superclass. Right? This is referred to as method overriding. So the toString method in the geometric object class returns the string representation of a geometric object. So this method can be overridden to return the string representation of a circle. You see, although in the superclass geometric object, it has a method called toString, but this method also can be exist in the circle class with the same signature, with or without parameter, and the same return type as in its superclass. So this is called method overriding, meaning you override the method. All right. So instead the method goes to the superclass, it will call the subclass method. All right. This is the example of method overriding. This is the superclass. This one is the toString method, right, of the superclass. To override it, add the following new method in the circle class. So in the circle class, we extend the geometric object as a superclass, right? And then we create the same method name toString, but with a different implementation. Okay. So both methods can be used in the circle class. So to invoke the toString method defined in the geometry object class from the circle class, we use super.toString. Meaning if you want to call the method in the geometry object, the toString method in the geometry object, we must write super.toString. So with this, it will call a method in the superclass instead of the subclass. All right. So note the following: an instant method can be overridden only if it is accessible. Thus, a private method cannot be overridden. So because it is not accessible outside its own class, so that one, the method must be public. Okay, like an instant method, a static method can be inherited. However, a static method cannot be overridden. So only public method can be overridden. Right? So overriding means to define multiple methods with the same name and signatures. While overloading means to define multiple methods with the same name but different signatures. Right? You have multiple methods with the same name, different implementation. Some have parameters and some have 2 parameters and some have 3 parameters. That one is called method overloading. All right. While overriding means you define multiple method with the same name and signatures. All right. The parameter is the same. The method name also is the same. The written value, the written what do you call it? Modifier also the same. So the objective of both is same, which is to provide a new implementation for a superclass method in the subclass. You mean you create a new implementation of a superclass method in the subclass. All right. So this is the example of the overriding and also overloading. All right. We have on the left hand side is the A is a class test. This is the main method of class test. All right. And we have class B, which which is superclass of class A. Class A, you see, class A extend class B. So class test is the implementation class. So we have to here, class B is a superclass, class A is a subclass. So you write B, you just write class B, it can be superclass of class A. Class A extends B, you see. So this class A has one method which name is the same as class B method, which is P. The parameter also is the same. It has one parameter, but the implementation is different. One is the formula, it called system.out.println I times 2, while this method inside A call only prints I. Okay, so in the test class here, first it creates an A object, A equal to new A. This one calls new A object. So this one A dot P 10, and then A dot P 10 dot 0. All right. So which method this code will execute? Which one? Method in class B or method in class A? Anyone want to answer?
Method A.
Method A. Method A is correct. Yes, method A. All right. This is called method overriding. And then we have B here. We also have two class here, which is B and A. A extend B. So we also have the same method here, but this one instead of declare as a double the parameter is declared as integer. The same implementation here. So what do you think the code will execute? Which one? Which one? The
You
first one,
execute
A.P. This one?
in the first one, yes.
The first one will execute which one?
You execute the first one.
A method in what class? A or B?
Method integer type.
A, is it?
Yes.
Okay. Then the second one?
You run class B.
Class B, yes. Yes, it's correct. Because it follows what parameter, what value it passed to the method. You see, in this one A, no matter what number it passed, you will always call this method in class A because it is the same type, double. So this is called override method. So while in part B here, this one is called overloads. It has two different method with two different type of parameter passing. So it will call two different method. It will execute two. All right. So here the explanation, when you run the test class in A, both A.P and A.P invoke the P double method defined in class A to display 10.0. So when you run the test class in B, A.P invokes the P integer because we only pass 10 here without the decimal point method. So it invokes the P method defined in class A to display 10, and A.P 10.0 with decimal point invokes the P method defined in class B to display 20.0. So note the following: overwritten methods are in different classes related by inheritance. Overloaded methods can be either in the same class or different class related by inheritance. So overridden methods have the same signature and return type. Overloaded method have the same name but a different parameter list, right? So the object class and its toString method. So every class in Java is descended from the java.lang.object class. So if no inheritance is specified, when a class is defined, the superclass of the class is object by default. For example, the following two class definitions are the same. So, for example here, public class name is equivalent to public class name extends object. So it is important to be familiar with the methods provided by the object class so that you can use them in your classes, right? So this section introduces the toString method in the object class. The signature or header of the toString method is public string toString. So this is the Java class actually, toString. toString is the Java class. Oh, it's a method in the object class. All right. So invoking toString method on an object returns a string that describes the object. So by default, it returns a string consisting of a class name of which the object is an instance and @sign alias and the object's memory address in hexadecimal. So consider the following example. So we have a loan class here. We create an object, loan object equal to new loan. So when we print it out, loan.toString, we call the method toString. It will print us something like this. Loan, this one is the class name, and then alias, and after alias is the memory address inside the computer where it stores the object code. So this message is not very helpful or informative. So usually you should override the toString method so that it returns a descriptive string representation of the object. So for example, the toString method in the object class was overridden in the geometric object class as follows. So just now we see the geometric object override the toString method. So it return the new string, right? It return its new implementation. Okay, created on date created, and it returns color, and then it return the field, right? And the protected data and methods. A protected member of a class can be accessed from a subclass, right? So far, you have used the private and public keywords to specify whether data fields and methods can be accessed from outside of the class. Private members can be accessed only from inside of the class, and public members can be accessed from any other classes. So often, it is desirable to allow subclasses to access data fields or methods defined in the superclass, but not to allow non-subclasses to access these data fields and methods, right? So to accomplish this, you can use the protected access modifier. This way, you can access protected data fields or methods in a superclass from its subclasses. So use the protected modifier to enable the member of the class to be accessed by the subclasses in any package or classes in the same package, all right? So to prevent extending and overriding, we use final, modifier final. So you may occasionally want to prevent classes from being extended. So in such cases, use the final modifier to indicate that a class is final and cannot be a parent class. So the math class is a final class. The math class here is in Java class. The string builder, and string buffer classes are also final classes. And these classes cannot be extended. The final classes cannot be extended. So the following class A is final and cannot be extended. So we declare a final class as public final class A, meaning that we don't want any class to extend this class A. So we declare it as a final, all right? So you also can define a method to be final. So method also can be defined as final. So final method cannot be overridden by its subclasses, meaning that the subclasses cannot overridden the method which is declared as final in the superclass, all right? For example, following method M is final and cannot overridden. So public final, method M here is final, and if any class extend test class, the class cannot override this M method, all right? It cannot have any M method inside the class, right? That's all. Any question?
Any questions?
For protected, the subclass is the class that extend the parent class is considered as subclass, correct?
Yes.
Oh, okay. And the final means that it still can. Final mean it still can be invoked or cannot.
It can be invoked, but cannot be extended. Yeah, any class.
Benny, mungkin you can give example if you still not understand. Okay, maybe many of us, of the student lah, okay, keep thinking why the overriding and overload tu, Encik Indruan.
Over. Overriding and
Overloading tu kan. Kenapa? Kita guna ke dekat dalam application tu? Oh, sorry.
Overriding and overloading.
Means memang apa kepentingan dia dalam code kita or any or the application.
Normally you override a method when the implementation is different. Let's say you have a superclass, right? Like this one. This one, class B, right? This one is the superclass. The implementation is different, right? So you override it by declare the same method name and same parameter, but the implementation is totally different lah. Maybe you want to calculate the perimeter just now, perimeter. So the perimeter formula for a circle and rectangle is different, right? That is called a method overridden. You want to use the same name, get perimeter, but the calculation is different. That's one of the example lah. Okay.
Okay. Okay, ada soalan lain yang di chat?
What is the function toString method is mainly used for? Like I have to print out the object name and I use toString method or something like that.
The toString method is actually from object method. The standard implementation is, this one is the standard implementation of the toString. Yeah. So when you call any object in Java, any class, you create an object from the class. You can call this method. You can call this, although it don't have this method, right? toString. It's from the standard library, Java standard library. You can call this one, this method toString from any object, even though your class don't have this method. So it will print something like that lah, something like this. The class name and this one memory allocation for the object lah. This is the standard library lah. Because every class you create in Java will extend the object class in Java. So the object class itself has toString method. It has other method as well. So one of the method is toString. So anytime you can call this one, even though your class don't have this toString method, and you can also override this one toString method if you don't want toString to print out, to give you the output, this output, you can override this toString like this one. Totally different implementation. It already, the class already override the object method, the toString method of the object class. So when you call from the object, right, your any object you create in Java, so it will print out like this one, a new one. It will not give you like this one. Okay.
Mungkin dengan bahasa mudahnya.
Bahasa mudahnya
Boleh ada atau boleh tiada?
toString ni memang ada dekat
Java.
apa, dia memang ada lah. Bila kita create satu kelas macam circle tadi tu, walaupun circle tu tak ada method ni, toString ni.
Saya pernah pakai toString, tapi dia macam ni. Kalau saya letak satu object name called circle, after I put like circle C1 equals to new circle, the object name is C1. So after I use, I want to print out the object name C1, so I have to type in again string C1.
C1 dot toString,
Like that.
yes, C1 dot toString. It's like a normal method lah. It's like your own method. But you don't have the method, right?
Oh, ada soalan dekat sini. By Muhammad Aiman, what is mean by same or different signature? Kat mana ya, Aiman? Slide nombor mungkin boleh tuliskan.
Slide nombor 3. Silap.
Same signature. So that method must be defined in the subclass to override same signature and the same return type as in, meaning semua sama, method name sama, parameter pun sama. Mana tadi? Ni override signature ni maksudnya dia lah, dia punya the method name P sama, P. The second one pun P, subclass dia pun P. And then the parameter also ada double. Satu parameter, double, and then dia punya return also sama, void. Same signature. This one, overloading, different signature. Double and integer, different. One different means different signature. Boleh?
Okay, faham sir.
Okay.
I want to ask, can you extend to multiple Can you extend a class to multiple superclass?
Can.
So you write extend one class and then another extend one class.
Extend, normally we extend comma. If I'm not mistaken, or extend another one. Extend and then extend again.
Boleh tulis contoh kot Encik Izwan.
Contoh,
Ini
ni kan? Tak boleh.
oh okey.
Class A, extend B. Extend B. Lah. Multiple class lah, dia extend.
Okay.
Mungkin Encik Izwan boleh tanyakan kot kat student coding yang mana yang diorang mungkin nak more explanation, more example.
Boleh, boleh. Macam mana? Ada soalan lagi ke?
Yang girl hari ni diam. Banyak boys ramai boys yang tanya soalan. Ni Cik Zan, kita bagi masa lagi 3-4 minit untuk bagi diorang cari soalan-soalan untuk ditanya.
Okay.
So pada pendapat Cik Izwan lah, daripada bahasa-bahasa yang lain, programming languages yang lain, apakah kekuatan yang Java yang sekarang kami belajar ni berbanding programming languages yang lain? Dia stabil sampai sekarang?
Ya. Because it's object oriented lah. Mm,
Only that. Then it.
one of it lah.
Mhm.
Mm.
Tak ada soalan lagi. Kalau tak ada soalan lagi, kita sekejap, saya berhentikan recording.